the good news is this isn't very complicated. We have graphed exponentials before, and there is a relationship between the logarithm and the exponential. So what we're going to do is graph both to figure out what that relationship is. So let's start with just a basic 2 to the x. If I asked you to graph that, you had these on the test, you had to make your t-chart. What 3 points did I say you had to plug in? Okay, what's 2 to the negative 1? 2 to the 0 and 2 to the first. So we can graph these. Negative 1, 1/2, 0, 1, 1, 2. Remember, it had a horizontal asymptote at 0. Never actually hit there. And it looked like that. What is the domain of that one? And what about our range? Okay. So that's what we've done before. Today we're going to be graphing these logs. If I want to graph that log, what I recommend is change it to an exponential first. So if we use the definition, you start at the base, so it would be 2 to the y equals x. If you were going to plug in points, would you plug in your points for x or for y? Y. Good. It's an exponential, so let's do the 3 points. Negative 1, 0, and 1. So 2 to the negative 1 power is 1/2. 2 to the 0 is 1, and 2 to the first is 2. What do you notice about these order pairs? Yeah, they're opposite. What's it called when the x and y flip roles? They're inverses of each other. Good. So if we graph this, we have 1/2, negative 1, 1, 0, and 2, 1. We can plug in more things, but what happens is our graph looks like this. I don't have a horizontal asymptote this time. What do we have? A vertical. So the red is my logarithm. It is the inverse of the exponential. Since the exponential had a horizontal asymptote at 0, x and y flip roles, the log has a vertical at 0. What is the domain of my logarithm? 0 to infinity. If you're looking at that red one, it starts at 0 and goes on forever. The range, if I'm talking about my y's. Notice we've talked about how the domain of the function is always equal to the range of the inverse. The range of the function equals the domain of the inverse. So logarithms and exponentials are inverses of one another. That means they're order pairs. The x and y just flip spots. Domains and ranges flip. The horizontal asymptote becomes a vertical asymptote. So we are going to graph all these logarithms today. What we're going to do to graph them is just change it to exponential form and then plug in the negative 1, 0, and 1, just like when we were graphing those exponentials. So here is our first one. I want to graph f of x equals log base 1/3 of x. So if I were to change this to an exponential, you start at the 1/3. F of x is the same as what variable? Equals x. So if I make my t-chart, You always put -1, 0, and 1 in for the exponent. Since y is my exponent, I'll plug those in for my y.
Could you plug in like -3, 0,
For the x?
for
For
the y?
the y? Yeah. I don't think it'll make it easier though, because like a -3 would turn into a 27. Okay. -1, what's 1/3 to the -1? 3. 1/3 to the 0 is 1, and 1/3 to the first is 1/3. My directions on these will be to have a minimum of 3 exact points, so you could put in 3 different points. It doesn't matter, but we usually pick these just because they give us the nicest values that we can get. So if we plot these, 3, -1, 1, 0, 1/3, 1. So again, your axis is the vertical asymptote. My graph just looks like this. Any questions, guys? Look at Alright, my recommendation on problems like these, just like when we did exponentials, we graphed parent functions and then did transformations. That's what I want to do here. My parent function is just the plain log, so we y equals log base 3 of x. That's my parent. What will this plus 2 do to my final graph? Okay, so if you change this to exponential, we're going to do 3 to the y power equals x. So you're plugging in your -1, 0, and 1 for your y. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. Okay. 1/3, -1, 1, 0, 3, 1. We know if we're doing a parent function, we go ahead and draw that just as a dashed curve. When I move this thing to the left, what else is happening? Yeah, my asymptote's moving. My asymptote right now is at 0. If I go left, it's now at -2. Just like with an exponential, if we moved it up or down, we had to move the horizontal with it, and I do expect you to draw that asymptote in. With the log, if we move left or right, you need to move your asymptote. So now just take each point left 2. I also asked for domain and range. What's the domain of this? Parenthesis on the -2, it's an asymptote, we're not actually hitting it. And the range? The range will always be negative infinity to positive infinity. The only thing that can change is the domain if your graph moves left or right. You okay? On B, what would I graph for my parent function? So that means 4 to the y equals x. Plug in -1, 0, and 1 for your y. -1 gives me 4. 0 gives me, and 1, 4. So 1 work -1, 1, 0, 4, 1. Alright, what's my transformation this time? Will my asymptote move? No. It's at 0, moving up or down does not change that. What's the domain here? Range? Any questions so far? I want to do just 2 more graphing examples. I'm going to put one up here. I want you guys to graph the parent function, and then we'll talk about the transformation together, okay? So both of these have the same parent function. Oh, they do not. Never mind. I lied. Let's do this one real quick. Both of these have the same parent function. So I want you guys to graph that to start us out. What's the parent function? Just your regular log base 5. So we'll graph 5 to the y equals x to start us off. So your point should have been 1/5, -1, 1, 0, and 5, 1. Okay, so that's my parent. Now I have to figure out what these other things are doing. A 2x. We struggled with these a little bit when we did transformations. Anything attached to the x does the opposite of what it says. So instead of multiplying our x's by 2, we really need to divide them by 2. So like this point was 1/5, -1. If you divide your x by 2, it's 1/10, -1. My graph isn't hardly big enough to put that in there. This was 1, 0, so if you divide that by 2, it's 1/2, 0. Okay, this was 5, 1, so if you divide the 5 by 2, you get 2.5, 1. What this does is just horizontally shrink my graph. You just took it and squeezed it in. So that's my log base 5 of 2x. I'm going to go ahead and graph the other one on the same graph. This one, if you make your x's negative, what does that do? Changes the sign on your x. It's like flipping it over the y-axis. So if you think about your original, you had the point 1/5, -1. So now the point would be -1/5, -1. We had 1, 0, so it'll go to -1, 0. We had 5, 1, so it'll go to negative 5, 1. So if you have a negative in front of your x, makes all your x's negative, just flips it over the y-axis. Alright, do you guys have questions about graphing these things? Change it to exponential and do transformations? The last thing I want to do is a few examples with just finding the domain without drawing the graph. So if you have a graph, you can get the domain from it. But without, we can still find our domain. When we talked about logarithms yesterday, I told you that in a logarithm, the inside part is always positive. Okay, so if I want to find this domain, all I have to do is take my argument, which is x minus 1, and set it greater than 0. Add my 1 over, I get x is greater than 1. How do I write that as an interval? 1 to infinity. Okay. B. My argument is just x. I don't care if there's a minus 1 on the end. All I care is the thing I'm taking the log of. So my domain is just x is greater than 0. So how would I write that? Okay. Let's do a couple more. Log base 3 of the absolute value of x. This tells me the absolute value of x has to be greater than 0. Now that's a little more tricky, right? We don't really know how to necessarily solve that. But we have graphed absolute values, haven't we? What's an absolute value graph look like? It's a V. You have 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Where is this graph greater than 0? Above the axis? Almost. It's above 0 here. It's above 0 here. What's the only place where it's not above 0? At 0. So this one can essentially be everything except 0. So it's negative infinity to 0, union 0 to infinity. So sometimes those graphs can help us if we don't remember or know how to solve it algebraically. This one is above 0 everywhere except 0 itself. Last one, x squared minus 4. Okay, we have solved quadratic inequalities. We talked about how we can't just add a square root across an inequality, but it's been a very long time since we did that. X squared minus 4 factors into x plus 2, x minus 2. And then what we usually did is looked at a graph to help us from there. We know the two places where it equals 0 are negative 2 and positive 2. If you graphed it, this is just a parabola. So where is this graph above the axis? Negative infinity to negative 2 and good. And we have to put parentheses on the 2 and negative 2 because we can't have equal to 0, just the greater than. Alright, any questions? this is a pretty short section, that's really all there is. So I have a handout posted on Classroom for you, and you have the rest of class to get it done, so you can possibly not have any homework for the weekend.